Bright Tuty. Every student matters.
Here if you see what we are given with, you can see there is a table given. Okay, they are saying the shape of the top surface of a table is a trapezium, right? The top surface is a trapezium. We have to find its area if its parallel sides are 1 meter and 1.2 meter and the perpendicular distance between them is 0.8 meter. So can you find out the area of this top surface of the table if this is a trapezium? Yes, definitely. We know area of top surface, that is a trapezium only. You know, you can name it always A, B, C and D. Top surface ABCD is equal to, what is the height? 0.8 divided by 2 into the sum of parallel sides. The sum of parallel side is 1 meter plus 1.2 meter. Right? Square meter will be our answer. Okay, so this is what we are going to do. Here also meter. So meter into meter will be square meter. Either you write meters inside or you don't write the units inside the brackets, just write square meter at the end. So it will be 0.4 meter into 1.2 plus 1 is 2.2 meter. So meter into meter is square meter. We get 4 upon 10 into 22 upon 10. 22 into 4, just to see, 4 2s are 8, 4 2s are 8 divided by 100 square meter. So 0.88 square meter. This is the area of this top surface of the table. What we were given, students? We were given a table and we have been given its top surface in the form of a trapezium. We are asked to calculate its area when we know the parallel sides, okay, and the height. And to find the area we just need these three things: the measurement of the two parallel sides and the height, that is the perpendicular distance between those two parallel sides. That's what we need to find out. We have placed in the formula and we have calculated. So every time you have to put the formula like this. You get marks for formula. Do not forget to write the formulas in the answers. Okay. Here is another question. It says the area of trapezium is 34 square centimeter. Okay, so we will write the given things first. So what is area of trapezium? Area of trapezium is 34 square centimeter. Length of one of the parallel sides. So length of parallel side. So we will consider it as A, suppose. Okay, it is given to us as 10 centimeter. We are given the height also. Height H is also given, that is 4 centimeter. We have to find another parallel side. So for another parallel side we will consider that as B. So we have to calculate B. What is the formula for area? We know the formula for area is H upon 2 multiplied with the sum of parallel sides, and the area is given as 34. So H is how much? H is given as 4 upon 2. One of the parallel side is 10. We have to calculate the second one and equal to 34. Okay. So here we will have centimeter, right? And here we have square centimeter. Square centimeter we have. Okay, so how to find it out now? Here also we have square centimeter. So how will you find out? Just see, we will have 2 2s are 4. So 2 into 10 plus B is equal to 34. So this implies that 10 plus B is 34 upon 2, that is 17. So 10 plus B is equal to 17 and B is equal to 17 minus 10, that gives us 7 centimeter. So one of the parallel side is 10, another parallel side is 7. So using the formula of area of trapezium, that is half into height into the sum of parallel sides, we have calculated the second parallel side, that is 7 centimeter. Right? All clear? Okay. Here is another question. So it is saying length of the fence of a trapezium shaped field is ABCD, that is 120 meter. That means what we are given with? We are given the sum of the four sides. Length of fence means the boundary. So we are given AB plus BC plus CD plus DA, and that is given as 120 meter. Now we know BC, we know CD, we know AD. We have to find the area of this field. To find out the area of this field, we know the length. Just to see, AB is the perpendicular distance. So we can calculate AB by using the perimeter that is given. So AB would be calculated, and AD and BC are already given. So we can apply the formula of area of trapezium. So AB will remain as it is. BC is 48 meter plus CD is 17 meter plus AD or DA is 40 meters, equal to 120 meters. So AB will be equal to 120 meter minus the sum of these, right? So let us add them. We have 48, 17 and 40. 8 and 7 is 15, carry is 1, 1 and 4 is 5, 5 and 1 is 6, 6 and 4 is 10. We have 105 meters. So if we subtract 105 meter, what will be the length of AB, students? It will be 15 meters. Right? Now if AB is 15 and AD is given to us as 40 meter and BC is given to us as 48 meter. So can we find out the area? Yes. Area of trapezium ABCD is equal to height. Height is how much? 15. 15 upon 2 into the sum of parallel side, that is 40 plus 48. So here you can write the formula h upon 2 into a plus b, where h is the height and a plus b is the sum of parallel sides. So 15 upon 2 multiplied with 40, and 40 is 8, so we get 88. 2 ones are 2 4s are 8, 2 4s are 8. 15 into 44. Let us multiply. 4 5s are 20. Carry is 2. 4 1s are 4 and 2 6. Then again 60. 0 6 6. So 660 square meter. Unit is meter. So area is going to be in meter square. Right? So what will be the unit? It will be square meter. Right? So 660 is the area of this trapezium shaped field ABCD. Right? So whenever we are given the perimeter, 3 sides are given, we calculated the 4th one also, and height is not given. The height is AB only, that is one of the side of the trapezium, because that is the perpendicular distance between the AD and BC, the two parallel sides. So that is only the height in this question. Okay. Okay, now we have another question. Here we have to find, just to see, the diagonal is given, okay, that is 24 meter of the quadrilateral, and then perpendiculars are dropped on it from the opposite vertices, and the length of perpendiculars are 8 meter and 13 meter. We have to find the area of the field. We know this is a quadrilateral, so we know area of quadrilateral, let us name it as ABCD. Let it be A, B, C and D. So you can just add the area of these two triangles, or also we learnt it that the area of two of this will be half into, see, the base AC will be common into height, the sum of heights. This is the formula for area of quadrilateral. And how does it come? You will write half into base into H1, and base is going to be same. This is the base B, and in this one also we will have half into base into H2 for the second triangle. So when we add them, we get this only. Now putting the values, half into base is AC here. AC is 24 meters, right? Into H1 is 8 meter plus H2 is 13 meter. So 2 ones are 2, 2 twos are 4. We get 12 meter into 13 and 8 becomes 21 meter. So we are going to multiply 12 with 21 and area will come out. 12 ones are 12. Right, 2, then carry is 1, 12 twos are 24, so 25 will come when we add the carry into it. So 252 square meter is the area of this quadrilateral, whose two heights and one of the diagonal is given to us. Clear? So applying the formula, we have simplified it, simply calculated it. Okay, now if you see the next question, they're asking the diagonal of a rhombus are 7.5 and 12 centimeter. We have to find its area. So if you recall the formula of area of rhombus, we have been given d1 as 7.5 centimeter. d1 means the first diagonal. D2 means the second diagonal, which is 12 centimeter. So area of rhombus is equal to half into the product of the diagonals. So we will write half into, what is the first diagonal? 7.5 centimeter. The second diagonal is 12 centimeter. 2 ones are 2 6 are. So we get 7.5 into 6 square centimeter. So let us multiply. 6 5s are 30. 3 is the carry. 6 7s are 42. 42 and 3 is 45. 45.0 square centimeter. That means the area of rhombus whose two diagonals are 7.5 centimeter and 12 centimeter is 45 square centimeter. Okay, let's move ahead. Here they are saying find the area of rhombus whose side is 6 centimeter and whose altitude is 4 centimeter. Okay, one of the diagonal is 8 centimeter long. Find the length of the other diagonal. So we are given one diagonal, we are given the altitude also, we are given the side also. So let us first draw the figure for it. So we are going to draw the rhombus. Suppose ABCD is the rhombus. I have drawn a rough figure. So ABCD, this is the rhombus. Each side is 6 centimeter, right? Each of the side is 6 centimeter because we know in rhombus all the sides are equal, and altitude is 4 centimeter. Right, so that means on one diagonal is also given, that is 8 centimeter long, one diagonal, and we have been given the altitude like this. A perpendicular is drawn and this is given as 4 centimeter and this is 8 centimeter the diagonal. So we know that rhombus is a parallelogram. Yes, it satisfies all the properties of a parallelogram. So area of ABCD will be equal to base into height because rhombus is a parallelogram. So you can just write rhombus is a parallelogram. So area will be equal to base into height. So what is the base here? Just see, 6 is the base and height is 4. So we get 24 square centimeter as the area of rhombus. Now we know the formula for area of rhombus. It is half into the product of its diagonals. So it comes out to be 24 square centimeter. Now one of the diagonal is given as how much? 8. Okay, so 8 into d2, that is centimeter, and 24 square centimeter. So if we cancel, 2 4s are 8, 4 centimeter into the second diagonal is equal to 24 square centimeter. So what will be d2 equal to? 24 square centimeter divided by 4 centimeter. 1 centimeter will get cancelled. 4 6 are 24. 6 centimeter is the measurement for the second diagonal, that is BD. Is that clear? So we were given the side length, the altitude. Altitude means the complete, for that complete figure the height is given. Okay, and then we are given one of the diagonal. So we use the formula of parallelogram area, that is base into height, to find out the area of this parallelogram, or we say the rhombus. We know rhombus formula is also half into the product of diagonal. So when we know the area, we know one of the diagonal, we can easily find out the second diagonal. Okay, so this is how we are going to attempt the questions. Let's move ahead. If you see here, there is another question. It is saying the floor of a building consists of 3000 tiles and the tiles are rhombus shaped. Each of its diagonal are 45 and 30 centimeter in length. That means, what are they saying? The tiles, how many tiles are there on the floor? 3000 tiles, and the product and the diagonals are given of that rhombus shaped tile, that is 45 centimeter and 30 centimeter. Then they are saying find the total cost of polishing the floor if the cost per square meter is ₹4. For 1 square meter, the polishing cost is given as ₹4. So can we find out the total area of the floor? We know, just see, there is a floor. let it be of any shape, and we have rhombus shaped, okay, tiles into it. Like this we have, this is one tile, this is second tile, this is third tile. So the rhombus shaped tiles are there, and how many tiles are there? 3000 tiles are there in total number. Can we find out area of one tile? The area, see, the tiles are covering the total area, so the total area of tiles is equal to the area of floor, right? So we will find first the tile area, and that will be equated to area of floor. So area of one tile is half into the product of its diagonal, because the tile is in the shape of a rhombus. So just see, half into 45 centimeter into 30 centimeter. So 2 ones are 2 ones are 2 fives are. So 45 into 15 square centimeter we are going to get it. So 45 into 15, let us multiply. 15 fives are, just see like this, we will multiply here. Let us do it. 5 fives are 25, 2 is the carry. 5 fours are 20 and 2 22. Right, then we have 45 like this, so we get 5 and 2 7, 4 and 2 6, 675 square centimeter. This is the area of one tile. Now area of 3000 tiles will be equal to area of floor, because these 3000 tiles are covering the floor, so the floor area and the total tiles area is equal. So it will be equal to how much? 3000 into 675 square centimeter, right? In centimeter we have it. Now they are saying that the cost of polishing the floor, if the cost per square meter, 1 square meter is given to be rupees 4, but here the answer is in centimeter. So to convert it into meters, what we need to do? Just see, 3000 into 675 into centimeter into centimeter. In 1 centimeter, 1 upon 100 meters are there, right? So for both the centimeter I have written this. Now 2 zeros got cancelled here, 1 zero got cancelled here, so we have 3 fives are 15, 1 is the carry, 3 sevens are 21 and 22, 2 is the carry, 3 6 are 18 and 2, right, and 10 is there in the denominator. So we get 202.5 square meter as the area of that floor on which these tiles are there. Now we know cost of 1 square meter, so you can just solve it here. Cost of 1 square meter, how much it is? Rupees 4. So we have to find cost of the total floor, that is 202.5 square meter. So multiply 4 and 202.5 square meter. What are we going to get? Let us multiply it here. 202.5 into 4. 4 fives are 20, 2 is the carry, 4 twos are 8 and 2 10 and 1, 4 twos are 8, and there will be a decimal. So rupees 810, right, we are going to get. So this is the cost rate, this is the cost of polishing the floor, rupees 810, right? So what we did, we first find out the area of total number of tiles. For one tile we calculated, we multiplied it with 3000, because there are 3000 tiles that are covering that floor, and then we converted the area into meter, because the cost is given for per square meter. After doing that, we have calculated the total cost, and that is coming to be 810, right? Okay, here is another question, and it is saying Mohan wants to buy a trapezium shaped field, its side along the river. You see, there is a trapezium side field, and on one side there is a road and another side there is a river. So its side along the river is parallel and twice the side along the road. So let us suppose the side that is along the road is x. So the side along the river is 2x, because it is double to it. Now if the area of the field is 10,500 square meter, area is given to us, and the perpendicular distance between two parallel sides is 100 meter, height is also given. We have to find the length of the side along the river. Okay, we have to find this 2x. Okay, so according to us, area of trapezium field or trapezium shaped field, it is equal to, What is given? 10,500 square meter. So we know the formula is h upon 2 into a plus b, that is the sum of parallel sides. Okay. Now what is the height given to us? It is 100 upon 2. Now x plus 2x, that is the two parallel sides, equal to 10,500. So you can cancel it with 50. So x plus 2x becomes 3x equal to 50 is in multiplication. Here it will go in division. So cancelling it, 5 ones are 5, 5 twos are 10, then 5 ones are 5, and then we get 0. Right? So how we are going to do it then? 5 twos are 10, 1 and 0 we got. So 1050 we have. So 3x is equal to 210. So x will be equal to 210 divided by 3, that gives us 70. So x is equal to 70 meters. But this is the side along the road. We have to find the side along the river. So side along the river, side along the river. What is the measurement? It is 2x. So 2 into 70 meter, that gives us 140 meters. Right? So what is the measurement of this side? 140 meters. Clear? So see, these are some practical questions. These are the application based question where we are applying the concept of or the formula of area of trapezium that we deduced in the starting of the lecture. Okay. Now here is another question. It is saying top surface of a raised platform is in the shape of a regular octagon. Regular octagon means each of the side is going to be 5 meter in length. Now find the area of octagonal surface. We have to find the area of this. Now what we can do is, the figure here is a trapezium. We can see definitely we can find out the area. This is going to be 5, right? Each side is going to be 5 and height is 4 meter here given. So we are going to join this because see the this figure is nothing, right? And by joining this like this, we get another trapezium. This is going to be 4 because it is the same trapezium, because it is a regular octagon and it is 5 meters and this is 11 meters. So area of, let us name it as A, B, C, D, E, F, G, H. Okay, so area of first the above trapezium, area of trapezium HGFE, it is equal to height upon 2 into A plus B. Height is 4 upon 2 into A plus B, that is 11 plus 5. So 2 2s are 4, 11 plus 5 is 16. 16 into 2 is 32 square meter. What about this ABCD? ABCD will also be this only 32. So we will write area of trapezium ABCD. It is going to be same 1 upon 2 into 4 into 11 plus 5, and that will be 32. We just solved it in the first part. Okay, so we have got both the trapezium. Now we are left with this rectangular region in between. So the length is 11 and the breadth is 5. So we will write area of rectangle ADEH is equal to base into we can say base into height also, or we can say just length into breadth, that is 11 into 5, that gives us 55 square meter. So area of octagon is equal to 32 plus 32 plus 55 square meter. So 32 and 32 is 64. 64 plus 55 we have to add. Just add them. 4 and 5 is 9. 6 and 5 is 11. So 119 square meter is the area of this octagon. I hope this question is quite clear, and you are now getting the thing how to apply the formula of trapezium rectangles to the polygons areas. Right, we are going to divide the figure into different rectangles, triangles, trapeziums, and then we find out the area of that polygon. Right? Okay, let us move to the next question. So students, in the next question, we see that there is a pentagonal shaped park as shown in the figure. This is the pentagonal shaped park. Finding the area, Jyoti and Kavita are divided into two different ways. So this is Jyoti's diagram, this is Kavita's diagram. Now we have to find the area of this park by using both the ways of Jyoti as well as Kavita's, and they're asking, can we suggest some other way of doing it? Right, so yes, we can definitely suggest other way of doing it. We can just divide it into triangles, like they have divided. She has divided into two trapezium, she has divided into triangle and a square. So we can just join, or you see, the diagonals can only be joined and form it. So if we join the diagonal, suppose like this, okay, so can we find it area? Just to see, we don't have that, right? So using these two we are going to find. So according to Jyoti, I am going to do it first. So according to Jyoti, what is this length? This is 15. And what is this total given? 30. This is 15. What about this height? Can we tell this height? Just to see, this is a pentagonal shaped park and we have to find out the area of it. So yes, we know that this is going to be the height and this is the diagonal, one of the. So from the diagonal we have drawn a perpendicular on this, right? And these are also 90 degrees each. So this is 15, right? So according to Jyoti, area of, okay, let me name it as A, B, C, D, E. Let us name this point as P. Okay, so area of the trapezium APDE, it will be height, that is, okay, half into the sum of parallel sides is 15 plus 30 into AP, right? Into AP. Now area of trapezium, the next trapezium is BPDC. BPDC is half into the sum of parallel sides, that is same, into BP. Let us add these both. Now we will add, so we'll get half into 15 plus 30, we get 45 into AP plus half into 45 into BP. So half into 45 is common and we are left with AP plus BP, because we don't know the measurement of AP and BP. But when we join AP and BP, it becomes AB, and AB is given as 15. Okay, so we will write half into 45 into 15. Okay, now we are going to multiply and then write the answer. So let us multiply 45 with 15. So 15 5s is 75, 7 is the carry over here, 15 4s are 60 and 7 6 75, divided by 2 we have. So 2 3s are 6, 2 3s are 6, 2 2s are 4 and 2 5s are 10. So 332.5 square meter is the unit. So square meter is the unit for the area. Again, I am explaining it what we have done. According to Jyoti, the diagram is divided into two trapeziums, right? Trapezium APDE, trapezium BPDC. Now we know the formula, but we don't know the height in this diagram. So height we kept as AP and BP. When we add these two, AP and BP, then we are getting the sum as 15, because it forms AB and AB is given to us as 15, so we calculated it, right? So then we multiplied 45 and 15, 15 5s are 75, carry is 7, 15 4s are 60, so 67 we got. 672 upon 2, so 2 3s are 6, 2 3s are 6, 2 2s are 4 and 2 5s are 10. So this is the area. Now according to Kavita's diagram we have to solve, right? So let us solve according to Kavita's diagram. We know for the first one we got the area is 332.5. Let us follow Kavita's diagram now. Okay, using the Kavita's diagram, just to see, I'm going to solve it for now. So this is 15, this is 15, this is 15, this and this are parallel as well as equal, so this is a square now. And what about this one, that the total is 30, so this much is 15. What about this? So this is also 15 if we see. Okay, so we will find area of triangle first. So area of triangle will be half into, that is base, into height. Height is also 15. Okay, and area of square will be equal to 15 into 15, that is 225, and it is 225 upon 2. So 2 ones are 2, 2 ones are 2, 2 twos are 4, and 2 fives are 10. So square meter is the area for both. Let us add them. 225, 112.5. We have to add them. 5 and 2 is 7. Then we get 2 and 1 3, 2 and 1 3. Right? So this is what we are getting. Okay, according to Jyoti's, we were getting 675 upon 2. So I wrote by mistake it as 332.5. But see, when we divide 675 with 2, 2 threes are 6, right? 0, copy 7, 2 threes are 6. We are left with 1, and then we copy 5, 3 sevens are, we will get, right? 2 sevens are 14, we will get. So 337.5 we are going to get. So 337.5 is the answer for Jyoti also, not 3325. Right? 332.5 is not the answer. 337.5, this will be the area. And for the second one also we are getting the same area. So just to see, the figure can be divided in different ways by students, but the answer for area, it is going to be same. Okay. Now in this question, we have been given diagram of the adjacent picture frame has outer dimensions as 24 and 28 as shown. Okay, this is a picture frame, and inner dimensions are 16 and 20. So if this is 16, this is 24, then how much is left? Then 8. So for this side and for this side, equal spacing is left. We have to find the area of each section of the frame if the width of each section is same. They are saying the width is same. So if this is for, this is for. Similarly, this complete is 28. If this is 20, then 8 is left. So this is also 4. The height is 4. Here also the height is 4. So we see there are 4 sections. First, second, third, and the fourth one. Right? It is divided into 4 parts. The outer part, that is the frame part. Okay. So we have to find out the area of each of the section. So first and second, if you see, first and second, they are identical. Third and fourth, they are identical. Right? Because they have the same side length and the same height. They are identical. We can find out the area of 1 and can multiply it with 2. So area of, I say, first trapezium. Right, or I say area of first trapezium, that will be half into, what will be the height? Just the height is 4 and sum of parallel sides. So this side is 20 and this side is 28. So 20 plus 28, 2 twos are 4. So we get 2 into 20 and 20, 48. 20 plus 28 is 48. 2 8s are 16. 2 4s are 8 and 1 9. So 96 square centimeter is the area of the first. What about the second? The second portion also has the same dimensions, same kind of trapezium. So it is also area of second trapezium. Okay, similarly we can find out area of third trapezium, that will also be equal to area of fourth trapezium. They both are identical. So in them we will write half into, what is the height, students? Height is 4. See, and what is the parallel sides? It is 16 and it is 24. So we will add 16 and 24. 2 twos are 4, 2 into 16 plus 24, just see, 10 and 20 is 30, 6 plus 4 is 10, so we get 40, right? We get 80 square centimeter as the area. So we have calculated of all the 4 sections. Now what about this middle section? It is a rectangle having the length as 16, having the breadth as just length and breadth as 16 and 20. So of this, if we find out, 16 into 20 will give the middle section area. That will be 320 square centimeter. Right? So like this we are going to find the area of each section. Right, and width is same as said. So this is how we have attempted question based on a picture frame or a photo frame. So you can also find out the areas. If you find trapeziums in the photo frames, you can get to know of what area is the boundary. Okay, that means the outer part is made up of what area. So what we have discussed, students, we have discussed area of trapezium, then area of quadrilaterals, area of special quadrilaterals like rhombus, like parallelogram. Then we discussed area of polygons. Okay, in area of polygons we had certain pictures or certain polygons like pentagons, heptagons, then we have hexagon also. We have practiced a question on octagon also. So we had different questions, and how did we find the area of such polygons? By dividing them into triangles, rectangles and trapeziums and applying the formula of these. So of any polygon, of any n-sided polygon, the area can be calculated by applying it or just dividing it into the parts like triangles, trapeziums, rectangles, and adding all these areas will give us the area of that polygon. So the major concept of this lecture was areas of polygons. Thank you so much.